Hi, I'm Paul Epps. We are working through the Leetcode must-do interview list. Today's problem, remove elements. Given an integer array, nums, and an integer, val, remove all occurrences of val in nums in place. What does that mean? The order of the elements may be changed. Then return the number of elements in nums which are not equal to val. Okay, so an example would be helpful here. We'll get to that. Let's see. Consider the number of elements in nums which are not equal to val. And we'll let that be k. So to get accepted, you need to do the following things. Change the array nums such that the first k element of nums contain the elements which are not equal to val. The remaining elements of nums are not important, as well as the size of nums. I don't know what that means. Return k. I mean, I understand that part. I understand enough to do that. Okay, the custom judge. The judge will test your solution with the following code. We probably don't need to look through that. What we want to see is like an example. Okay, let's do it. Let's look at example 2 here. So we get it. The input is nums. It's an array of integers. According to the constraints, the integers will be between 0 and 50. Is that right? Yeah. Val will be between 0 and 100. So yeah, it's possible that none of the elements will be equal to val. And the array length is not going to exceed 100. All right, so we've got that array, and val is 2. Now, if we return 5 and we rearrange nums such that everything that is not equal to 2 is at the front of the array in any order. It doesn't matter what order. So your function should return k equals 5 with the first 5 elements of nums containing 0, 0, 1, 3, and 4 can be returned in any order. And it doesn't matter what is beyond k. Okay, yeah, so they just put underscores. I mean, I don't know what they would be other than other than 2s, but okay. Okay, we're going to use the input from example 2. So that's nums, and our val is 2. We're gonna start a pointer initialized to 0, or an index when we get to coding it. Initialized to 0, and we're going to do a loop through this array, one loop through the array. And I'm going to keep track of the loop with a tick mark up here. This works kind of like the first pass of one pass of an insertion sort, where you go through, and if you find a number is in the wrong place, then you swap it. That's what we're going to do. So anytime that we find a number that is not equal to val, we're going to swap it with wherever the pointer is currently at. And then we're going to increment the pointer. So we start out with the first number, 0, is not equal to 2. We're going to swap it with the pointer. The pointer is actually already pointing at 0, so we kind of swap it with itself, but we also increment the pointer. So the pointer is now here, and we go to the next element. Is the next element equal to 2? No. Swap it with the pointer. Again, the pointer is already pointing at it, so we are just going to increment the pointer, which is now here. We go to the next element. Is that equal to 2? Yes. Well, in that case, we don't do anything except go to the next item. Is that equal to 2? Yes, we don't do anything. Go to the next item. 3. Is that equal to 2? No. So we're going to swap with wherever the pointer is at. So that means that the pointer is here. So we're going to take the 2 and 3 and swap them. So now 3 is here and the 2 is here. And again, when we do a swap, we increment the pointer. So it's now here. Okay, go to the next item. 0. Is that equal to 2? No. We're going to swap it with the pointer. So 0 and 2 will be swapped. That's now 0 and that is now 2, and we'll increment the pointer. It's now here. Go to the next item. 4, is that equal to 2? No. Okay. Swap it with the pointer. So 4 and 2 are going to swap. That is now 4. This is now 2. Increment the pointer. Go to the next item. Is that equal to 2? Yes. All right, so we're done. We didn't get quite the same output as the example, but the order doesn't matter as long as we have 2 zeros, a 1, a 3, and a 4. So the array is fine, and what we're going to return is the pointer. And the pointer is at index 0, 1, 2, 3, 4, 5. So we'll return 5. The pointer is at index 5. And that's it. So let's look and see how we can implement it. All right, so we're going to set a pointer to the, let's see, we're going to set a pointer to first element in the array. And then we're going to set up a loop, a for loop. We're going to go through process every element in the array. So for int j equals 0, j is less than nums dot length j plus plus. Are the numbers equal? Well, actually, let's check for the numbers being not equal, because if the numbers are equal, if the number in the array is equal to val, we don't do anything. So let's check for them being not equal, and we'll say if nums j is not equal to val. Okay, then we'll do a swap temp equals nums I, nums I equals nums j, nums j equals temp, and increment the pointer. All right, once we get done with that, public, and that ends, let's see. That's the if. What is that? Okay, after the for loop, after that, it's going to be, no, not there. It's going to be here. Return the pointer, I. All right, let's run it. Oh, I'm going to have to move this up. I'm going to have to move this up. Compile error, not if num, okay, I forgot a parentheses there. Run it again. Okay, that's accepted. That just runs some basic tests. Let's submit it. Start the study plan. No, I'll do it later. Let me scoot this over so we can see it a little better. Runtime 0. So it's pretty fast solution. What about the memory? Oh, wow, the memory usage is pretty good too. All right. So that is that's it. That's the solution. Feel free to like, subscribe, and see you next time.